Okay, so today, let me do a self-introduction. I'm Ziran from open source group of Samsung Research UK. Today I also have my teammate Phil. Phil Conwell. He's joining me. Phil is based in France and I'm based in the UK. So in today's talk, we're going to talk about our practice in the lab on how we bring JavaScript into Internet of Things from embedded device to smart gateway. So, start the talk. I will just briefly discuss why we chose JavaScript in Internet of Things, and then we go further, talk about the challenges we're facing to bring JavaScript into IoT. And first, we look at to bring JavaScript in embedded devices. Then, at this point, we're going to introduce you JavaScript, an ultra-light JavaScript engine developed in Samsung. And then we look at the two very popular IoT platforms which actually build on top of JavaScript. The IoT platform will provide direct JavaScript APIs to developers. So the challenges on the gateway side is a lot less thanks to the Node.js framework. Then after we introduce you the JavaScript engine and the gateway, which actually we choose the Mozilla Things gateway. So we're going to put them together, show you a simple demo, see how you can make a very simple end-to-end IoT system in using these two platforms. And after demo, Phil is going to introduce you the Web of Things technology we've been using in this demo. And then he's going to go further. So he's going to show you some very exciting light demos. So he's going to show you how to control his sensor actually at home, how to control it from here remotely. So why JavaScript in IoT? Well, can I ask how many of you consider yourself as JavaScript developers? Well, pretty much. I would say more than half. Yes, that's the main reason. One of the main reasons we're choosing JavaScript is popularity. So according to the Stackflow annual survey, well, for the 5th year in a row, last year, 2018, for the 5th year in a row, JavaScript is the top language choice for developers. So the other thing is maturity. The language itself and like frameworks around it are maturing, and productivity. Because JavaScript is open standard, language itself is very OS and platform independent. Also, there are big, vast third-party libraries around. So what does this mean? I think you probably got it. So actually, it probably very likely means that you actually take less time to introduce your products to market. So it all sounds very good. I mean, JavaScript sounds so good. But then we have to bear in mind that JavaScript is actually a scripting language. So we see it running in web on the back-end server, thanks to Node.js. But then in IoT, there are a lot, heavily embedded devices. So how do you have a JavaScript running with a constrained device which has a very limited CPU, memory, and the resources? So yeah, this is diagram actually showing the thing gateway could be the RAM could be 2 KB, which is quite a pretty minimum. Obviously, it can go high end like 1 gig, but most of them will see 32 KB, 64 KB, or something like that. So here comes the ultralight JS engine, JavaScript by Samsung. So the name of Jerry actually came from Tom and Jerry. So we're thinking very smart, fast. Yeah. So JavaScript basically focuses on devices which actually memory size from 32 KB to 256 KB. So, I mean, because you're thinking that you're having a JavaScript engine running it, you do need a reasonable memory size. But this engine is really ultra light at this moment, because the RAM size, obviously, as we said, you probably look at 32 to 64. This is the minimum. And then ROM, you look at 200 KB. Also, we actually have this binary compiled for ARM SUM2, which is around 160 KB, and actually further reduced to 140 KB at this moment. So we mentioned that initially developed from scratch by Samsung in 2014. And in 2016, it's actually transferred to JS Foundation. How many of you are aware of JS Foundation? That's great, yes. Under JS Foundation, we have about, at this moment, about 31 projects. So all JavaScript project. So we do recommend, if you're a JS developer, go there and have a look. You might find something really interesting. From IoT point of view, I would say like Node-RED is quite relevant, good too. So at this moment, I mean, the engine is very self-contained, it's very portable, and API is very mature. So you can have the engine run on its own. But the API from the engine is a C API. So what's next is for JavaScript developers, they want JavaScript they want JavaScript APIs directly. So here we have. Oh yes, sorry, I haven't finished. So yes, optimization and performance has been very top priorities, and their new features keep on going. And the community really in the last few years just developed so fast, rather than, not only the Samsung developers are being active, also we have like committers from Intel, ARM. So this actually means that a lot more OS and board, physical hardware support. So this is a list of the hardware we can find. You can find the initial supporting code on GitHub. And the product. So this is Fitbit Ionic smartwatch, which actually released last year, which more significantly to JavaScript is actually using JavaScript as a platform for development. Yes, now I'll come back to IoT platforms. There are two main platforms. One is IoT.js, which actually very, very closely coupled with JavaScript, because this one is also developed by Samsung. And the hardware support, of course, is very much in line. And the main philosophy behind IoT.js is basically do a small version, Node.js. So when the team developed, actually trying to make it small, also backward compatible with Node.js, which means that a lot of code you're using IoT.js API developed, you can run in Node.js environment without any modification. Well, assuming that the modules also, you're supporting. So the other one is Zephyr.js by Intel. This is very tailored to the vendor, actually. So it's tailored on Intel Zephyr OS, and also the board, the physical board support is also quite a limited number. And the philosophy, as we said, also similar. We want to be portable between this embedded IoT.js platform to Node.js. So let's have a look at JavaScript on Smart Gateway. In our case, we use the Things gateway from a Mozilla project. So we have Mozilla actually has a Things cloud, which actually basically just try to make gateways collaborate in different geography area work together. And we have Things framework. I think later when we talk about Web Things APIs, you probably have a better idea. And then we have a gateway. So this is the architecture for gateway. So initially the prototype for gateway was actually based on Node.js. And later they actually introduced the concept of adapter, which is a language adapter. So it's had a support for Rust and other languages. So at the backend, as we mentioned earlier, is actually based on Node.js. The gateway basically actually claim that there's some good security and also authorization authentication scheme. Well, so you have the feature basically like we do have HTTPS, so backward tunnel using PageCat and the OAuth framework. Then for authentication, so JSON Web Token is actually this method is used. Obviously, you have other choices. So now we introduce you to JavaScript. We introduce you to Mozilla Gateway. Let's put it together. Let's see a simple demo. So this demo I used in one of my talk last year in July, but I think it's such a good simple demo. Actually presented pretty much covered the framework and the technology we talk today. So I'm just give a quick talk on this. So on the demo, basically we have a Raspberry Pi 0 running Raspbian and Raspbian JavaScript IoT.js, and then we actually have this blink T light. So it's actually an array of 8 LEDs, very bright light. It's actually a Raspberry hat, so you can hang on the GPL pins. So the gateway itself actually provide the add-on. So basically, Club Hand add-on, which actually detect the audio input. So what we have is we basically program the blink T light as a web thing using the web thing API proposed by Mozilla Gateway, Mozilla IoT team. So there is some similarity with this web things API with W3C API. Do have a check, you know. And so this one we have this web thing. We program blink T as a web thing, which actually is recognized and can communicate with Things Gateway. So this, in Things Gateway, we actually also configure a rule. Basically, what the rule is very simple. They provide this UI, so which means that they actually what you do is you can configure rules between add-ons and things. So the add-on basically is clap hands add-on. So our rule is when you clap hands, and then you turn the thing on off. So next one actually is a video. I'm not going to show it today because they're very exciting light demo later. So if you're interested, do go to our I actually upload this into YouTube. You can also check from my slide anyway. Let's look at how it works. From the Raspberry Pi side, we have Raspbian, JavaScript, LT.js. Because the blink T light is talking to GPL pins, so we need to have a GPL module built in. So this actually, at that point, I need to mention that LT.js actually provides quite a few built-in modules and extension modules. So built-in modules also quite a similarity, try to follow the line. Node.js is doing like a event file, those modules. And then we have WebThing IoT.js. This is the base code to support WebThing APIs in IoT.js environment. So this one, I think Phil is going to talk a lot more details on it. And on the top of it, we actually program the thing. So yeah, that's it. So I would like to hand it to Phil, talk to you more about WebThing's API.
Thanks. So here we go. Here it is. So this is my smart home in the box, and this is a WebThings Mozilla dashboard where you have all the devices connected. So there is a couple of sensors and actuator. So here I can decide to turn on the light, to change the color because there's different properties. So every thinks, hey, we missed something. I didn't explain the source code. So we only have 10 minutes, so let me back to the code. I will make the demonstration just after. Ziran, where is your screen? Okay. I need to go back to the presentation. Sorry for the confusion. So yeah, what are web things? Basically, they are HTTP server, no more complicated than that, and they're all connected to the gateway using a REST API. So it's not a peer-to-peer model where you have different things talking together. Everything is decided by the gateway. And there are different ontology, but it's quite simple. This is basically just properties describing different things. They are using JSON description, and it's following a schema, which is a specification on proposal on at W3C. And you can implement it in a different language, but we're in the JavaScript room, so it's JavaScript time. So I made a fork of the actual Node.js module made to build the web thing, but I made it, I simplified it to make it running on IoT.js, which is similar to Node.js, but with less advanced feature. You have only ECMAScript 5.1 support, so you need to transpile and eventually adapt. A couple of features have been removed, but the basics is working the same. So that's the cool thing, is that if you deploy using IoT.js on, let's say, Linux, and you want to deploy to a microcontroller, this is actually the same code, only the engine is changing, of course. So if you want to do IoT, you have support for all kind of input-output, and some connectivity feature like HTTP, HTTPS, and a couple of other modules like a WebSocket, which is quite interesting for real time, and yeah, MQTT and so on. So if you want to implement it, I try to make it the shorter possible. So maybe it will not compile, but you get the idea. So a thing is defined by a name. So here is some sensor. Then I create a server, and I assign this thing to a server, and then I can just open a request on my host name, and I get the description of the thing. So what we have here is a thing without any properties. So not very useful, but you can from the gateway you can scan, you can add it by IP, and then it will display a widget on your screen. So the next step is adding a property. So here is a simple one. I made a color sensor. So a color is in a web domain described it as a string. So when we create the property, so here I'm inheriting property. So this is not modern JavaScript, but it's quite simple because it's only 2 lines. So I assign a value to my property, which is a color. Here it's black. And I need to add some semantics to describe this is matching the color property model in the schema from Mozilla. And obviously it's a read-only value because you cannot change the sensor value. Okay. And then if you make a request to the host name, you have the description of the property, and you have a different endpoint. So let's go on. Now, so this is the same example. I try to make it smaller. So if we are creating this sensor, this property is reflecting the value of a sensor object. We can be a simulator of a real sensor. We have just an event function, which is on reading, which is updating the value by this notify exception external update. And then from the UI, you have the matching color, which is updated. So if we make the request explicitly from command line on a different endpoint, I have a JSON describing the color. So it's no more complicated than this. I'm pretty sure you are doing more advanced JavaScript development, but you can run this on a microcontroller. So let's go now back to the demonstration. Where is this? Okay. So yeah, so what I explained yesterday, just before. And here are the sensors, the value, and The smartness is in this tool, which can be useful to create some logic between different elements. So, for instance, I created one, let's say, oh, it's quite difficult to control the, so let's say I'm using as input my temperature sensor. I'm not using Unity, so I'm a bit lost. And I can decide to connect to, let's say, my light over here, and say that if the property of the temperature is above a threshold, let's say, oh, I'm sorry because I didn't take it. So if it's above, let's say 10 degrees, then there is some event going. So something I can show also is that on my dashboard, I have also made something which is not real IoT, but I made where is it? A Mastodon actuator. So everyone knows the difference between a sensor and an actuator. That's simple. The sensor is reading a value, and the actuator is doing an action. So the one I created here is something that just sends something to the Mastodon network. So I'll compose them, and it will be updated in a couple of seconds. There it is. So let's say the use case I have with this flower is when my flower is out of water, I'm sending a notification to my neighbor that he should water my flower, because when I'm speaking on conference, I could not care of it. And no, I also shared what I cannot show you more. Yeah, I have also some sensor here, which is not connected to my home, but it's in my city. So where it is? Do you see a air quality sensor? Okay, 4. So this is a level of. Okay, 5 is up. Let's go. So yeah, I'm here in Rennes, and I have a sensor which is measuring the air quality. So where is it? Well, it is somewhere. And anyway, the value. Okay, I will find it by clicking. But if you have any question, you can prepare them now. Okay, here it is. So here is my home under the lake. So the value is 4, and I should find it again here. So you can imagine all kinds of use case of interaction between device staying in your home and things on the internet, and everything is possible. It's flexible. So sorry, I'm out of time. If you have any question, feel free to ask here on the outside and on IRC in the Mozilla IoT channel. Thank you very much.
Thank you.